Hey everyone, I'll be doing a little different video today. Going to be doing a video of how to run Arista inside of CML. So there's a lot of information out there about how you can run Arista inside of GNS3 and EVE-NG, and that's all well and good. And you can also run Cisco in those EVE and GNS environments as well. But the one thing you can't do in those environments is run Cisco images legally. The only place you can do that is inside Cisco CML. So if you want to run a multi-vendor lab, or you work in a multi-vendor environment and you want to do some tinkering, you can bring Arista into CML, and that's what we're going to go through today. So it's a little tricky. It's not too bad, and hopefully by the end of this you'll be able to do the same as well. So we're going to run through it step by step. The only thing I'm not going to do is go through the download of the image. We'll go to where the image is and sort of point that out. In all honesty, my download speeds at home aren't the best, so I'm kind of skipping over that for everybody's benefits. But once you create an Arista account and go into their portal, you can come over here into support, software download. Then down here we're looking for the vEOS lab. The C is the container based, the V is virtual, and that's what we're going after. And there's going to be two files in here that you're going to want to grab. One is going to be this boot serial file, this ISO right here, and you need that to sort of pre-boot the actual operating system. And right now, the latest operating system here is 4270F. We're going to grab this virtual image. This is the 32-bit image. Down here, we have a 64-bit image. I've not played around with this one, so we're going to stick with the 32-bit here. So I've already downloaded those, and the first thing that we need to do is get these files ready for CML. So we just can't bring the ISO directly in or the VMDK directly in. We need to get them converted over to QCOW2 files, which are part of the QEMU set. I think that's how you pronounce it, QEMU. So I'm going to transfer these images over, and I sort of have this already staged here. This is my local computer and my development Linux box over here on the right with WinSCP. We're going to upload them real quick into my Arista directory. And while that's running, I'll go ahead and connect into my dev box so we can do the rest from there. So there are two applications you're going to need from inside Linux to make this work. One is DD, and that should be on any Linux distribution out there. The other is going to be the QEMU image tool that lets you convert the image over to the QCOW2 format that CML requires. So the very first thing, let's make sure it's actually finished transferring first. My goal is to do this in one take here, so hopefully no cuts, no edits. Fingers crossed, we'll see what happens. So we've got our boot and our vEOS VMDK file. The only one of these that we actually need to use DD to convert is the boot file. So we need to turn this from the ISO into a raw. Sorry, not raw. That's later on here. We just need to convert this guy from an ISO to an image. There we go. My brain's catching up with me. So we'll go sudo dd. Our input file is our boot file. Our output file is a boot as well, but instead of ISO, we're going to rename it to IMG. All right, you can see here that it brought the file in, spit the file out, and now if we look in the directory, we have an image file alongside of our ISO. So the next thing we're going to do is convert it over to the QCOW2 format that's needed. And you'll need the QEMU image tool, which is part of the QEMU utility package, so you'll need to make sure that you've got that guy installed. So to check if you have it installed, so one real easy way is to type in QEMU IMG, and if it doesn't show up, then you don't have it. Oh, you gotta spell it right first. QEMU IMG. It's not installed, but to install it, it's part of the QEMU utilities. So we'll go ahead, grab that, install that. Yes, please install. And once that guy finishes up, QEMU. Now it's at least giving us errors when we try to run it. So we'll start with the so our format here that we're converting from is raw. We're going out to a qcow2 file, and the file we want to bring in is our aboot.img, and then we want to output aboot again, but instead of img, it's going to be qcow2. So now we have a qcow2. We're going to be doing the same thing for the VMDK file, but instead of the format being raw, we're going to indicate that it's a VMDK. QEMU image convert from VMDK. Output is qcow2. Bring in the VMDK, putting out a qcow2 file. And that one may take a little bit longer. That file is definitely larger. So there we go. So now we have our two qcow2 files. So we'll go ahead and grab those off of the server. So we'll refresh here. Bring them back down into our same directory. And while that is going, we'll get into CML. That's not the right IP. Here we go. So the first thing we're going to do in here, after we're done transporting back up, is jump into Tools and go to Node and Image Definitions. From there, we'll go over to Image Definitions, and we're going to manage them. So we've got our files that we want to upload. So we've got our aboot file. Upload that guy first. And then we've got our vEOS file, the actual operating system. There we go. Now if we refresh here, we see that we have the two files. So we're going to head back into the nodes and image definition section, over to node definition, and we're going to create a new one. So we're going to call this Arista vEOS. We'll stick with the same description. Bringing them over as a router. Now our prefix here is how these are going to show up inside of CML. And if you've not used CML before, which hopefully you have if you're watching this, but when you drag one of the pre-built Cisco devices out, and this is just me being very particular about the way things appear. If you bring in, let's say, an iOS XV image. They're going to put a hyphen there and then increment the numbers on the ends. I'm kind of particular and I want this to show the same way, so I'm going to call it vEOS dash. So if you don't put the dash in there, you won't have the dash in the prefix. Icon, we'll make that a router as well. And our label on the choice screen will say Arista vEOS. So then we need to set up the simulation parameters. So the actual file itself that we've brought over, it's a virtual machine. It is true blue virtual machine. If we took that VMDK file and loaded it up inside of ESXi or virtual VMware's virtual desktop appliance or software, you'd be able to actually run it in there. So what we're doing is programming CML to launch that virtual machine. So there are different ways that you can configure different devices. This should work for you for the Arista stuff. It does work for me. And really here it's listed as a server, which, because if you think about it, okay, yes, it is a switch or a router, but at the heart, it's still a server running inside there. So we're going to go ahead and say that simulation driver is a server. Go with the disk drive as IDE. Give it 4 gigs of RAM, 2 CPUs, and we'll tell it not to occupy any more than, I'll say, 75% of CML CPU. The network driver we'll leave as we'll set to E1000. We don't need to worry about the data disk size, the boot disk size. There's no graphics adapter that we need, so we don't have to worry about that. We do have a loopback. We'll just call it loopback 1. We'll give it 1 serial port. And we'll give this device 10 physical interfaces. Call the first one management 1. Add another interface, call it Ethernet 1. And then we can click this button here to increment the last interface. So once we hit this, Ethernet 2, 3, 4, 5, 6, 7. We'll give it 11 interfaces, 8, 9, 10. So there we go. Now when booting up here, you can set a timer of how long does CML wait until it can assume that the device has fully booted up. And there's sort of 2 ways that you can go about this. One is to set a timeout. So, okay, after 240 seconds, it's going to assume that it's booted. Or we can add in a boot line here so that when CML sees localhost login come through the console, it's going to know, hey, I'm fully booted up. Not worrying about PyATS. We're not dealing with any of the other, the image or the per node definitions. We're going to leave all of this static, not generating a configuration, and we're not doing any CML-based provisioning. Go ahead and create. We have our new definition, our node definition. So now we need to link the image to the node. So we will create a new image definition. And the version we uploaded was 4270F, so we'll call this, oh, look at this. Apparently I've done this before. Well, that's not even fully right, but we'll go with it. Oh, no, OF. Is it OF? Here, I'll just jump in here and steal it straight from there. Yeah, looks like a 0 to me. And then we will label it the same. And then call it Arista version. So now you'll remember we uploaded 2 images here, and inside the CML web interface, they don't give you the option, Cisco doesn't give you the option to select both. It lets you select one or the other. So the order doesn't really matter. If you select a boot, the next steps we're going to do over vEOS on the Linux side. If you go with vEOS, we have to switch over to the boot side. So you'll see as we jump into that. So we'll go ahead. And all the way at the bottom here, we can see the definition, the other definition that we made, Arista vEOS. I'm not going to touch any of these because we already set them through the node definition. And we'll just say create image. Okay, image definition is created. So we could go in and we could at this point drop an Arista device into a CML lab, but it's not going to work until we link the other file. So to do that, the first thing you're going to need to do is SSH into your CML environment. Now, out of the box, that is disabled. So we're going to turn on SSH. So you have to go into the administrative side of the operating system, into the Linux backend. And then when we go into, it's either services or applications, I forget. Here we go. So from here, going to services, and on the filter, I just typed in SSH. We need to turn on the SSH daemon. Click it, enable it. After a few seconds, there we go. We are running. So the thing to keep in mind here, or just to realize, is that this SSH service actually runs on port 1122. It's not the typical SSH port. So CML occupies the traditional SSH port for doing the console ability that you can use within it to jump into devices once they're configured. So to get into the Linux backend, they just shifted over to 1122. So we will go ahead and connect over. Already there. Connect in using your same sysadmin password, and there we go. We're inside the controller now. So what we need to do is grab this other file that currently isn't linked to a definition and move it over to where the boot file is, where we actually made the definition. So by default, on the CML controller, that is in var local viral to drop folder. Permission denied. Sudo list. And there is our qcow2 for the vEOS file. So we're going to steal that path right there. And we need to jump over to the var local viral2 ref plat folder. So we'll just stop here real quick. And you can see there's CD-ROM, diff, and work. So CD-ROM, if you've copied all of the images off the CD-ROM into CML, they'll live in there. But diff is where we're going to go because that's where the different stuff is kept. So we have two things in here. We have node definitions and the viral base images. If we jump over to node definitions real quick and look at the Arista entry in there, you'll see here's all the stuff that we already put in. So here's our 11 interfaces, the naming. Here are the drivers that we set, the RAM, the CPU, all that good stuff. That's not what we're looking for. We want to get into where the images are stored. So now you'll see our Arista folder in there. And you'll see we have our boot qcow2 file and then a YAML file. So step one is going to be to get the other file moved out of the drop folder over to here. So we can sudo move from our drop folder, and we want to select the VE. I should have copied the file name as well. I could we want that file, and we want to move it to the directory we're currently in. So we have moved over our file. So something that CML does on the back end that you now have to do is, if you look over here at the permissions, the boot file is already set to read write, read write. This guy is only set to read read, so we need to change the writes on there. Going to chmod, it is 664, that file. And now you can see there both read write, read write. Then we need to edit this YAML file. So if you're not familiar with vi, I completely understand that, but I will walk you through what you need to do here. Vi is a very delicate text editor for Linux, and it is very unforgiving. It is probably the worst part about it. So what you want to do is hit the letter I to go into insert mode, arrow down to disk image, or actually just under disk image to read only, press enter, and we need to insert this second disk image here. So we do that by saying disk image 2 colon and then the file name of that second image. So there's other platforms that if you try, other non-Cisco platforms that you may try to bring into CML, that you'll need to do this to add additional images. It'd be nice if Cisco put this inside the actual graphic, the UI for CML, but since they haven't, this is the way you go about this. So to save and quit, you're going to hit escape, then colon, write, quit, so WQ exclamation mark, and then hit enter. So now if we say cat Arista and we look at that file, you can see that we've now got our second image on there. So the images there, we've got all of our definitions made, we've got the permissions set. The only thing left to do now is to reboot CML or restart the services. Since I had to enable SSH and I'm already in this interface, I'm going to go back in here, say CML2, restart controller services, and restart services. I may do an edit here depending on how long this takes, but we'll see. That was not very long at all. So we'll go back over to CML, and I'll just log out for good measure and log back in. Oh, the system is not ready. So it may take a little longer than I thought. There we go. Now we're back up. So we're going to create a new lab. We'll call it my Arista lab. Oh, my Arista lab. And over here on the right, you'll see Arista. All right, so we'll drag one of these in. And you can see earlier how I was talking about the naming. So now it's going to increment when we bring one more over. So now we've got two. We'll go ahead and connect them together. And we'll connect them on ETH1 to, oh, we'll just do ETH2 for fun. Create that link and start our lab. Go over to the console and watch our new devices boot up. Should boot pretty quickly here. They don't take too long to boot, and everything's virtual. If you have solid state drives, things will go even faster. But once these get booted, the very first thing that I'm going to do here, and this isn't going to turn into a whole Arista lecture at this point. This is really just to kind of show that it's up, it's functional, and the two devices can see each other. But once we fully boot in here, the first thing that you're going to need to do is issue a command that's going to disable the zero touch configuration. So the default nature of these out of the box is going to be to reach out to see if there is Arista's cloud management platform, essentially, so it can pull down its configuration. But since we're doing this in a lab and that doesn't quite exist, we want to make sure that we don't get stuck in that boot loop. And I'm pretty new to the Arista platform myself, so I can't speak for what you might encounter in the field so much. But I definitely know, at least as part of this, the labbing process, unless you have gotten to the point where you have something like that connected in and you're really able to do a more faithful representation of what the real world might look like, just killing the zero touch is going to make it easier for you to work on, because if you don't, it's going to just keep rebooting. So we can see, hey, welcome to Arista. We've got our version going here, and CPU's jumping up a little bit because we do have them both booting at the same time. But once they're booted, everything should stabilize a bit for us here. Everything's looking good so far. Check on the other one while we're waiting for this one to come up. Console. Yeah, looks like it's only a couple steps behind it, if even. And once these get booted up, the only thing that I'm really going to do here is fire up LLDP and essentially just do a show LLDP neighbor, just to prove that we have layer 1 connectivity between the two devices. It's not a super in-depth test, but it's definitely enough to prove out, hey, not only did we boot the devices, but they are able to communicate with each other, they're able to see each other. So if you are getting yourself into a nice Arista lab or a nice cross-platform lab, you're going to interface Arista to Cisco or to Juniper, or build a whole network out using vEOS and Juniper and Cisco and Arista, that you have to have that communication working. So, which, I mean, I guess that's a little too obvious. All right, well, this is definitely taking longer than I thought it might, but it is first boot. They are still working. See CPU ramping up again. Should have probably only done one instead of two. Other ones at the same stage. That's fine. Memory's ramping up. Maybe that means something. And here we are. So they even give you the zero touch provision alert right there. So first login is admin, no username, or no password. Zero touch cancel. And it's going to cancel the zero touch provisioning. We'll jump over here because it'll probably be close behind. Admin, zero touch cancel. There we go, same thing. So it's going to reboot one more time on us. Hopefully this won't take as long. If it does, I'll just fast forward the video through that. If you are still watching at this point and haven't skipped through this, one interesting thing that I learned doing a little little research for this video was on the history of the DD commands, which loosely stands for copy and converts, but it's called DD. And apparently at some point in time, whenever DD, I believe it was being ported over from Unix to Linux, I don't recall the exact story, but essentially CC was a reserved command inside of the C compiler, so naming something else CC couldn't coexist with that, so they just changed the name from CC to DD, and now we have DD. And you can fact check me on that. The internet told me it's true, so it must be true. Don't mind my obnoxiously large water bottle. So that definitely felt a little bit faster that time. We'll go ahead and log in. So the last thing I'm going to do here is enable LLDP to run, which if you are a Cisco user, you'll find using Arista a pretty natural experience, or natural. There's some good crossovers between Arista and Cisco, put it that way. And issue the command LLDP run. Not too complex there. Jump back to our second switch router. Actually, before I run it, we'll say show LDP neighbor. There are no neighbors. Oh, nope, there is a neighbor. Maybe it does run out of the box. I may have been incorrect there. So there we go. I learned something along the way too. So we'll go, we'll jump back over here. We'll rename this guy host name Arista1. Jump back over here, and now we're just playing around. Arista2. Hop back over here. And there we go. So we see it locally on ETH1. It's over there on the neighbor on ETH2. It's named Arista2, and that's what we set out to do. So there you go. That's getting Arista set up within Cisco CML almost from start to finish. The only part we skipped up front was downloading the images and creating the Arista account if you don't have one already. It's relatively straightforward as long as you keep an eye on making sure that you've got the image put together correctly, and that very last part where we brought the image over, you absolutely have to do that or you won't be able to boot any of this up. So I hope you found this helpful. If you do, give me a like, give me a subscribe, and I'll be doing some other videos, bringing some Juniper stuff over, see what other things that we can put inside of CML so that you can get some really good cross-vendor experience inside of it. Take care. Bye-bye.